functions and stuff like that. But you've always wanted to learn some coding, Zarine? Well, look, you came in here and you dropped 5 subs. That's got to be worth a little quick programming lesson, isn't it, guys? I feel like that's a fair call. That's an absolutely, let's do that really quickly. Okay, what would you like to know, Zarine? Because we can go and show some simple stuff. Just quick 101. All right, look, let's go. Well, this is a .NET development environment. This is what people usually do for, this is Microsoft's development environment. So what we can do is we'll move this up into this. So usually there's a solution folder. So that's what this file is. And it ties lots of bits of code together. But we don't need to worry about that. We're just going to go here and I'm going to use a command line and I'm going to run a command to make a new project. So .NET is our development environment, and I'm going to go new console. And what that's going to do is make us a new console application. So I'm going to add that to our solution. We're going to add our existing project that we've just made, our example. We should call it like Zarine example or something. So with that, we'll now have some code that we can run. We have a program, and in order to write something to the console, we can use something called a class. And this class is used to, classes are used to reference groups of code. This particular class is used for the console, right? And so if I go and run this now, so I'm going to run this code. So here's the code. If I go and I run it, what we're going to get is a new console window because we're running the console program. And there it is. And just imagine this console will do something, and we're going to write a line to the console saying hello world. So this could also be Zarine. Hello, Zarine. If we run that, we'll get a new console output result. It'll do what's called compiling, where it turns the code that you've written into instructions for the computer, and then when it runs those instructions, we get that here. But you can do more than that, right? You can go, let's see, 1 plus 1 is, and then I can do something like 1 plus 1. So this is called a string. Strings are just words, and these are called numbers. Numbers like this are integers, and you can do arithmetic with integers. So you can use an operator, which is in this case, it's the plus symbol, and I'm going to go take 1 and add 1 to it, and the result of this is going to get computed. This programming language is called C#. Most programming happens in something called a development environment or an IDE. This one is called Writer, and I think Writer is the best one for .NET development. Like we talked about, .NET is the Microsoft environment that I like working in. Though these days, .NET can run everywhere. It can run on your Mac, it can run on a Linux server, it can run everywhere. So just to demonstrate, I'm going to give that a run again. And if we run our example, now what we're going to see is, hello Zarine, 1 plus 1 is 2. So if we wanted to, let's say we could do this. We can say there is a variable, or abbreviated to var, and it's called the result, and maybe let's just 2. We can say the result of adding 1 and 1 is saved out as 2, right? So if I run this again, let's rerun that. You can see that the output isn't going to change at all, Zarine. So we go, hello Zarine, 1 plus 1 is 2, right? And so we could also say, instead, let's do some math. And now we can, from here, we can do output. So that's what console.writeLine does, but we can also do input. So I could go result equals console dot read line, and that will be the first result. So so we'll say write line give me the first number. And let's actually just zoom this up so you guys can get a good look at it. Give me the first number. And then we can also say first number. And then we can say something like, give me the second number. So now let's read two numbers. Second number. And now I can go, so now we can output that. Right line, the numbers you gave me are, first number and second number. So let's run that, and you'll see something different happens. I'll be honest, using abbreviations would have saved me so much time when I was making the graphing calculator games. Graphing calculator games. What were you working with there, Zarine? You made some games for graphing in calculator? That's like with a calculator? That's interesting. It's very cool. Not sure if they would have accepted abbreviations. Abbreviations are an interesting thing because it's like sometimes you can abbreviate too much. But you know, abbreviations can also make things more concise. So, all right, the first number we'll say 1, for instance, and we'll say 2. And you'll see the numbers that you gave me are first number and second number. But what would happen now, just like random questions are in, I want to demonstrate something to you. If we did like console dot, what if we did first number plus second number? So we'll write console.writeLine result was. So let's rerun that. And quick guess here, Zarine, what that actually means. So first number is 1, second number is 2. The numbers you gave me are 1 and 2, and the result was 1, 2. So I did this to make a point. Things have types, right? So notice here how it says string with a question mark. So what we actually got from these results was what we actually got from these results were not numbers but strings. So we got the word, because like the word 2 describes a concept, which is the number 2, right? And so what we're talking about when we got these numbers in was like we got them in as strings, but we can't treat them like numbers. So if we add these two things together, it's going to add the two strings together. So we need to do something first. So to represent a number, not a word for a number, we need something called an integer. And so what we can do with that is we can convert the string into a number, and we can do the same with the second number. And that second number, and now if we add our integers together, we get a result, right? So now let's rerun this and show you what's actually happening. So let's see, the first number is 10, down here, 10 and then 5. The numbers you gave were 10 and 5, and the result was, interestingly, 20. So what do you think happened there? So I put first number in, I should have put second number in. So it added 5 and it added the second number 5. And so what you saw there was we actually had a bug. We added 10 twice instead of 10 and 5. And so that's how bugs happen. That's a completely intentional bug. I totally meant to do that. Guys. That wasn't me making an error, doing some really, really basic, so we can do like really big number, and then you'll notice that can overflow. So that's an example of where like integers have limits with the amount of memory that they have. But more manageable numbers. So we can, to demonstrate, if we wanted to handle that number, we could, instead of int, we can use something called a long. So longs have more information than others. And so like, so to int 32 is too small for that. So to int 64, now we're gonna get a long. So 32 and 64 here is referring to the number of bits, the number of binary bits. So like numbers are saved like this, right? So that is 1. If this was binary, that is 1. That is 2. That is 3. And then if you wanted 4, yeah. So hold on. Yeah, that's right. That's 4. So that's 4. So what this is like, remember how you, if you're going to represent another, so the number of like, when it says 64, it's the number of bits in the string that you actually have with your number. So we're getting a little off track into a completely different tangent, but binary actually isn't that confusing. I was about to explain this. So like, you know, if you've got like, you've got ones, you've got tens, you've got hundreds. So if I wanted to go like 123, I'd go a 3 in the ones column, a 20 in the tens column, and a 1 in the hundreds column, right? That's how you like, you know, that's how you represent numbers. And I probably, to make this less confusing, I could have done this like that. So 123. Binary works like this. This is the ones column, then the twos column, then the fours column, then the eights column. So every time this doubles, right? 1, 2, 4, 8, and then 16. And what you essentially do, if you wanted to make the number 1, you have a 1 in the ones column, right? And you have a 0 in the 2 columns, in the same way that you have like a 0 in the tens column, right? So if I wanted to make the number 3, I would go 1, 2, and 1, 3. If I wanted the number, you know, 7, then I would go like this, because I've got 4, 5, 6, 7. If I wanted 6, I could go 4 and 2. So that's essentially it, Zarine. That's how binary works. In the same way that if you think like your, you know, we think of numbers that way, you can just store numbers with switches this way, right? Because these zeros and ones are ons and offs. And this is just like a way to encode numbers. So yeah, so essentially like 64 means like bits and stuff like that. I'm sorry I side quested a little bit there, but with the explanation, but yeah, you can kind of see like now this can be treated as numbers. So, you know, 1, 2, 3, 4, 5, and the second number could be 2, 4, 6, 8, you know, 9, whatever. We're just giving numbers, and you can see that we'll now like add those numbers. And if you wanted to like subtract, you can do subtraction here, you can do division, you can do multiplication. So like, yeah, you get all this like this basic arithmetic and like input and output. Those are some really, really basic things. And the one more thing I'll probably show here. So we'll go like private void add numbers int number 1 and number 2. And it's actually going to give us back an int. Actually, no, maybe it's not. We can return add numbers. So these are called functions. They have inputs and outputs as return types. So what are you going to return is the result of adding those numbers. And so instead of doing our add numbers here, we can now call our method, and that would be the first number int and the second number int. Though, you know, longs, maybe we don't need to demonstrate that because integers are shorter than longs. Int, and then that can be 32. Now all is well in the world again. And so now this represents what's called a function. So you can call functions like that. So yeah, some really, hold on. Yeah, that did work. So, you know, 1 + 1 = 2. So yeah, that's just like some real basics, some real basic programming in case you were curious about it, Zarine. So we do a little bit more advanced stuff here on the stream, but like I know a lot of people here watching the stream are like you guys are hanging out here for hours watching me do some of this advanced stuff, and I realized like I never actually stop and break down the basics. And I had that thought to myself yesterday. I was like, you know, if somebody comes and does something amazing, like drop a bunch of subs, or you guys hang out all this time and sometimes you're like, I don't even know what's going on with this. I feel like I owe it to you all to just to stop and like explain a little bit as we go, so that those people who choose, like Snolzy, even if you're hanging around just because you think I'm a cool guy, oh my God, thank you, Zarine. Zarine, you didn't have to do that. You really didn't have to do that. That's an incredible additional 10 subs. Thank you. Thank you so much. I mean, okay, wow. Thank you so much, Zarine. I don't know, like, do you want me to keep going? Do you want to see some more, like, do you want to learn some more programming stuff? Because I tell you, like, programming is a bit like playing chess, you know? When you sat down, when you're a kid, you sat down with your, like, maybe your mum decided she was going to teach you chess one day, and it probably took her like half an hour to show you each of the moves that you could do. But once you learn the moves, like, there's a lifetime of learning that can be done with it, right? It's very, very easy to learn, but very hard to master. So what I feel like I can actually do here, if you like this kind of stuff, is I can show you the basic moves like that. If you enjoyed that, I'd be happy to go a little bit longer and show you some more cool stuff that we could do. But I mean, it's up to you guys. It's really up to you guys, because we can, you know, still we were going to do some, can I just see whatever you're developing for your program rather than wasting my time? Oh my God, Zarine, it is not a waste of time. There are a few things that I'm really passionate about in this life. One of which is making games and software engineering. I really like the process of making computer games. The other is teaching. I really love teaching things, right? And, you know, so I used to teach martial arts, but I also used to teach software engineering at a university. And I really love doing that. And so it is not a waste of my time. If you find this even slightly interesting, or there's somebody else here in the chat that also finds these like learning programming things interesting, I really would be into showing you guys that kind of thing. Yeah, martial arts. I'll take you, Snolzy. Come on, come at me, bro. Nah, yeah, I really enjoyed teaching martial arts as well. That was fun. But yeah, look at you all with you. I feel like that's an emote that we have to get in this stream right there. That's hilarious. Yes, yeah, that's the one. That's the one, Goldie. Yeah, I need the whole like, I know Kung Fu. Except instead of just like plugging into my head and instantly learning it, I spent like 15 years on it. If only we could just plug into the Matrix like that, right? Come at me, Rick. All right, maybe we'll do another one of these a little bit like later. Hello. I didn't even realize it was open. Cool. Is Luke's home? Okay. No, yeah, gotcha. See ya. Would be down for Keanu Reeves karate emote. Not a bad call. Not a bad call.